Right. Let's see who's going to be mathing at Friday at 9 o'clock, at 11 o'clock at night. So we're going to be mathing. Hello, hello, hello. Hello, 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 hello. Welcome, welcome, welcome. My name is Lynette, and we're going to be talking about the abacus. We are going to be doing this crazy thing called mathing on the abacus. Oh, that's right. So that was one of the things is trying to understand what we're going to do. So the first thing we're going to do is we're going to do some division. We can do some division. Hello, hello. We're going to do some counting. Let's do some counting instead. We're going to figure out what this thing is. This thing is an abacus, and this abacus helps me count and does math. We do abacus. We do adding, subtraction, multiplication, division. Hello, welcome everybody. Welcome Patsy and Sarah and Ifuna and Nursey. Okay, so what are we going to do? We're going to count. 1, 2, 3, 4. How do I know? Because there's this beam, there's this horizontal bar, and we know that this is 4. So then we have to know where 5 is. Hey, Bonnie, how's it going? Thank you so much for liking my like. So what's going to happen is we're going to do counting this beam, right? This horizontal bar tells me that it's being counted. So we have 4. 1, 2, 3, 4. Easy, right? Easy peasy. So this is actually 5. Hi, Martha. Welcome. Okay. This is 5. How do I know this is 5? All the top bead will always have a value of 5. Always will have the value of 5, right? So we have 5 and then we have 6. How do I know? Because all the bottom beads has a value of 1. So when we're counting, it's super easy, right? Simple to use, easy to understand. Welcome, everybody. Welcome. Hello, Jeremy and Zomina. Zulema. Okay, so we have 6, we have 7, we have 8, we have 9. Easy. And then just like how we write 10, we have 1 and a 0. Welcome, everybody. Welcome. We're going to be mathing on Friday, just so you know. You guys are very committed to learn about math on a Friday. Okay, so we have 10, 11, 12, 13, and then 14. How do I know? Everything that touches this horizontal bar is going to tell me that we're being counted. So these beads are being counted. None of these beads are counted. Why? Because they're not touching the horizontal bar. Because they're not touching the horizontal bar, these columns are now 0. But this one here is 14. So when we look, that's 15. And then there's 16, 17, 18, 19, and then 20. So when we're looking at it, it's easy to see, right? Simple to use, easy to understand. So when we're looking at it, we're just going to be doing this number. So why do I start here? The reason why I start here is because I have an indicator. I have a little label, and there's this little thing. There's this little thing that's the dot. This dot tells me that this is where I'm going to put my ones place. So because I put my ones place here, I have my ones, my tens, my hundreds, my thousands, and my 10,000. This is why this is 20. Do you see how it's 20? So when I do that, this is now 25. And we have 26, 27, 28, 29. Super easy. Let me know if anybody has any questions. Hello, Hamza and Mindy. Welcome. We're talking about the abacus, and the abacus tells me how to add and subtract and multiply and divide. We can do all of that all in the abacus. We can also do, but wait, there's more. We can also do decimals, and we can do decimals. That's as much as it goes. I mean, fractions is really just division, right? So we can do fractions, but that's not really much. Okay, so the first thing we're going to do is understand how to read the abacus. We have our ones, our tens, our hundreds, our thousands, and our 10,000s. So if you also notice, this one is also a dot. There's also an indicator here and an indicator here. The reason why there's an indicator, it tells me where the groups are. Just as we write 4,568, we did 4,568. So what I'm looking for is a piece of paper, and I just wanted to write down what it would look like. So when we write it, right? Whoa, that's not good. Come on. There we go. Okay, so what does this look like? It has 4,000, comma, right? 568. So that's what it looks like. Just as we write it on the abacus, just like we write it on a piece of paper, we do that on the abacus. And notice I have my 4, and that's where the comma is. This comma has no place value, right? It just sits between. But that's the same thing with the decimal. So if you notice, this is my ones, and then what's after that? This is my tenths, and this is my hundredths. So when I look at it, this would be 45. So if we were talking about money, it would be 4,568 and 45 cents. Welcome everybody, welcome. Let me know if you have any questions. We can do some adding. We are ready to do some adding if we all know how to read the abacus. So the first thing we're going to do is do the really simple adding. So some of the simple adding we do, we blew away the first part, which was understanding how to relate the numbers to the abacus. And so this is a book for preschool abacus and going into understanding how to do the numbers, what the numbers relate to on the abacus. So here is my book, and let me get to my adding and subtracting. So we have greater than, less than, and then, we have some adding. So this one specifically is just adding 4. So what we're going to do is we're going to add the 4. What does that mean? Well, if this is 5, we have the top beat that's 5. I'm going to put that on my abacus. And then what we're going to do is we're going to add 4. Thank you so much for the likes. Thank you so much for the likes. So, hey, Lady E, how's it going? It's morning for you. Early morning. Okay, so there's my 4. So what I want to do is I want to add 4 to the abacus. So I just added 4 to the abacus. So now my answer is, hey, Spanglish lady, my answer is now 9. So notice when I add it, it's just super easy because all I'm doing is I'm adding. Good morning. It's early, right? Early, like 5 in the morning for you or something. So here we're going to be adding this one. If you notice, we have a 0. Right? This is a 0 because there's no beads touching the beam. There's no beads touching the horizontal bar. That's 0. And then I'm going to add a 4. Easy, right? Super easy. Not a problem. Let's do something a little more difficult. How difficult can it really be? Well, there's the 2. Right? Okay. So again, here's my 5. So I'm going to add the 5. I'm going to be on this side, right? And then here I have 2. Oh, that's not too bad. It's a nice morning, not too early. So I just finished watching Spider-Man Far From Home. Anyways, it was number 2 with Mysterioso. It was pretty good. And then I was like, you know what? I kind of want to go live. So now I'm here. So this is 5. And then what we're going to do is we're going to add 2. We have 1, 2. So my answer is 7. Notice that I didn't need anything. I just moved the beads, and that's how we did it. So how do we read the beads? So let's read it. We have 2 and then 5. The top bead will always be 5. Anytime the beads are touching the beam, this is 5. So we have 5, 6, 7. And then we have 8, 9, and then we have 10. This is 10. How do I know that this is 10? Well, if you look, this is my indicator. My indicator tells me that this is my ones place. And this is my ones. This is my tens. This is my, it's Saturday. Yep, that makes sense. It's Saturday because it's still Friday night for me. I still have another hour of Friday because I'm in California. So my ones, my tens, my hundreds, my thousands, and my 10,000. So I'm starting here, so this would be 10. So after 10, this is 20, 30, 40, and then this is 50. 60, that's 60. How do I know 60? 60, right? 5 and 6. And then don't forget there's a 0 because this is my ones place. So I have 60, 65. Right? 66, 67, 68, 69, 70. Just like that. 70. Anybody have any questions? Welcome. Let me know if you have any questions. I know Bonnie has been coming in and out of my lives. Bonnie, do you have any questions? Boring person has joined, and Veronica and boring person still joined. Anyways, Lisi. So, okay, XOXO and Megan. Okay. So again, we're just talking about how to read the abacus. I'm. What are the 2 on the right for? Oh, the 2 on the right. Thank you so much for your question. I think that you're an octopus, but thank you so much. Okay, so the 2 on the right is when we do the decimals, right? So what we're going to do is, notice when we have our decimal, we have our ones, and then this is our tenths, this is our hundredths. Just like we write money. I'm on my way to bed soon. Oh, yeah. Heck yeah. It seems so interesting, overwhelming, but super interested. Oh, yeah. It's not overwhelming. Why would it be overwhelming? Oh, so here's my example. My example is this one. So if I did my 4, and my thousands. I do my 5, I do my 6, 8, 4, and then 5. Let's see. Okay. Whew. Seems so overwhelming, but super interesting. No, super simple. It's simple to use and easy to understand. Okay, so the 2 on the right, if you notice, I have my ones, right? This is my ones, the 8 is my ones, and then notice there's a decimal. The decimal happens between the 2 columns, just like we write. And so this is 45. So if this was money, this would be 45 cents, right? Easy. 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 Not overwhelming. It'll be fine because the way we write is exactly the way. Yeah, right? It's super helpful. Yeah, no. This is so let's take a step back. The reason why I count these beads is because it's touching the beam, right? When it touches the beam, I know these columns are being counted. So when they're being counted, then that's what it is. So this is 4. Why? Because it's all the lower beads, all these beads have a value of 4. And then this is 5. This has a value of 5. All the top beads has a value of 5. So we can, knowing that this is the value of 5, we can see that this is 6. How do I know? Because this is 5 and then 6. This is 8. 5, 6, 7, 8. And then we have 4, just like we did here, right? 4, just a different column. Because of the columns, just like how we write on the just like how we write on a piece of paper, we have 4, and then we have 5. Yeah, super. Was it simple to use? Simple to use, easy to understand, right? Right? Thank you so much for the follow. Thank you so much for the follow. Okay, so that is what counting on the abacus is. What we need to do in the very beginning is understand how we read the abacus. How do you do 100? Shani, thank you so much for the comment. So, how do I do a 10? Just like when we write it, right? I'm going to do 10 just so we get a visual. So, if you notice, this is my ones and this is my tens. So, just like that. That is my 10. That's it. So I'm going to count by tens. So 10, 20, 30, 40, and then 50, 60, 70, 80, 90, and then 100. So how do I know this is 100? Well, we do our ones, our tens, and this is our hundreds. So if you could see, because my camera, I'm always playing with my camera, so that's why I have the dot over here, and my dot over here is my thousands. So when I look at it, I can count by hundreds. 100, 200, 300, 400, and then 500, 600, 700, 800, 900, right? 900, and then 1,000. Easy. Hey, Dandelion, welcome. It's so late for you. Okay. Do we have any questions? So that's how we read the abacus. And we want to learn how to read the abacus before we start going into adding and subtracting. So before I continue on, are we okay? Do we understand? Wow, that's a lot of hearts. Thank you so much for the hearts. Thank you for the follow. Okay, question. So what happened at YO2AIRZ? Yes, so how do you do the 1 million? Don't be sorry. I love the questions. Wow, I never knew this was. I know, right? And it's the same time for me as it is for you. Yeah, it's a little late though. Yeah, that's what I'm saying. YO2. It's simple to use, easy to understand. Now, Shani, though, don't be sorry. No. There's no sorries. I don't accept sorries. The difference is it's a smaller abacus. So it's harder to do 1 million, right? Because this is only 7 columns. But then we look at it, right? We only have 10,000. So then I would graduate. I would graduate to the 13 column and then I can do it. That's what I do. So we do 1 million, right? We do ones, tens. Okay, ones, tens, right? That's 11, right? 211, 300, 3,000. 211, 43,211, 543,211. Oh, that's not it. So I got to go one more, right? No, this is it. So I got 9 million. I want $9 million. Who's that? Austin Powers, Dr. Evil, right? I want $9 million. So why would I start on the 13 column abacus? I would start in the middle because I have a lot more to go. But if your number is like super long, you can actually start over here. But I think a million digits for a million is probably pretty good. This probably could have helped me in high school. Oh, if I got the hang of it, right? Oh my God. When I learned it, I was like, oh my God. I actually learned it when I was old. So, and I'm older now. I didn't learn this Dr. Evil, right? So, I didn't learn the abacus till I was way old. But my kids know and they didn't like it. But they know. Do they have really good, I'm in high school. Yeah, you could do it in high school, but I don't know if your friends would be laughing at you. I'm just saying. I'm not here to say that it's cool. But it helps to understand how to read the abacus. I mean, I got my boys in school and they're in high school and they're like, yeah, I'm done. Hey, Rainy Night, thank you for the follow. Okay, so we know how to read. Shawnee, any more questions? I love the questions. Please ask me more. I love questions. Ask me more questions. Only about abacus. Only ask me about abacus. Yeah, I'm 42. No, it's not a little late because I learned it when I was about 30 or so, and I've been doing this for about 20 years. So I've been teaching abacus for more than 20 years, and I have a little school in Monterey Park, and I'm like, you know what? I'm gonna bring this to the internet. I'm gonna see what happens. You don't have any for questions? Oh, Shawnee, no more questions. Okay. Okay, so what we're gonna do is we're going to what are we gonna do? We're gonna do some adding. Let's do some adding. Wow, that's awesome. Yeah, my kids. I mean, my kids are old now, but I taught my kids how to do the abacus, and I feel like that they had a really good sense of number sense, and so it was kind of interesting because abacus is the gateway to complex math. So what does that mean? Well, we do a lot of things that really translates to algebra and to other bigger math. But the idea is to get the foundation. So what we're doing only is to understand, oh, you're very sweet. You make me feel so welcomed. Of course, of course. Please don't be sorry. I don't accept sorry. No, fantastic. Okay. Yeah, let me know if there's any questions because the only stupid question is a question that you never ask, right? So just ask away as long as it's abacus based. And yes, we will do math problems. I will do plenty of math problems. I just want to make sure that we all understand how to read it because sometimes when I start going through, people are like, I don't know what's going on. So I just kind of want to make sure that we're all on the same page about understanding how to read it. So we have 4, right? We have 4 and then 5. So this is 54 and then this is 64. Okay, so we're okay with that. What we're going to do is we're going to start doing some adding. Yeah, not a problem. We're going to do some adding. This is what we call simple adding. Why? Because when we look at it, we're not going to need, we have enough beats. So we have 2 and then we have 2. So this is 4, right? We know that this is 4. Now, if you look, now what we're trying to do is trying to lay the groundwork. So when we all start how to use the abacus, we start moving the beads. And the numbers are simple for now, but they get more complicated when the numbers get bigger. Oh, Brenda, that's not good. Don't say that. That's very hurtful. You have to be careful with the words you think because your brain's going to be like, yeah, that's right. But you're not too dumb. This is not dumb. You're not dumb. We don't know. I didn't know. When I first started, I'm just letting you know. When I first went to learn the abacus, I'm like, what is this stupid thing? Why do we need it? What's it for? And so when I started going down, I was like, oh my God, this is the greatest thing next to sliced bread. So thank you for the follow. I remember I learned this in first grade, but I quit. I wished I continued. Oh, yeah. It is a struggle to go through and to go through the bigger numbers because it gets a little hairy. So Brenda, don't be dumb. Don't say that. I don't accept that in my room. We do not say that. All right. What we're gonna say is I haven't learned it yet. Right. So we're gonna learn. When we look at the horizontal bar, we know that these are counted. The beads that touch the horizontal bar is counted. See? See? Right? Brenda, don't, yeah. So, Shani says, I was confused at first, but when you watch she teaches us and you understand it more. Take it step back. Take it a step back. We're not here to rush. I remember starting with my fingers. Yeah, I never started with my fingers. I just went straight to here. I know you could do abacus with fingers, but I don't know how to do that. I only know how to teach the abacus. And so we're here, and this is the horizontal bar. So the thing that we have to remember is the horizontal bar. The horizontal bar is what tells us what beads are being counted. So when we look, this is 4, just like a die, right? When we look, we know that this is 4. Same thing here. We know that this is 4. 1, 2, 3, 4. But then you're like, okay, well, I want to know what 5 is because I want to know. So 5 will always be the top bead. 5 will always be the top bead on the horizontal bar, just like here. So this 13 column abacus is the same function. It's just different colors. So when I look, this is 5, and then this is 5. So this 5, that's 5, right? So then we do 6, and that's 6. Well, how do I know? Because all the lower beads has a value of 1. So when we count, this is 6, this is 6. So when we do it, and then this is 7, and this is 7. We have 8, and then 9. So we had a question, how do I do 10? Well, just like we write, 10 is a 1 and a 0. Let me see if I can find my papers. Right? Just like we have a 1 and a 0, this is not 10. This is a lot of numbers. There's a lot of numbers. Let me clear it out. So we have 10. We have 1 and 0. Well, how do I know? Why are you here? Well, I'm here because if you could see, there is a dot. This dot is my label. YO2. Look, I'm reading it. Okay, so let's do that. So this dot here, I'm sorry, I completely had a brain fart because I was trying to read and trying to figure out what I was saying. So we have this indicator. This indicator tells me that this is my ones place. That's why I start from here. And then anything after here is my decimal. So let's do a number. We will do 789. Notice I went from left to right. I didn't go from right to left. I did not go from the ones to the tens to the hundreds. I went from the hundreds, tens, and the ones. Does that make sense? Yeah. So so the first thing we need to do is we need to understand how to read the abacus. When we understand how to read the abacus, then we can actually start going into adding and we can go into adding and subtracting. And then, depending on how far we get along, we can actually do multiplication and division, which is easy to use. Simple to use, easy to understand. So the first thing we're going to do, and that was what we were doing here, is we were moving the beads to see what we were doing. So when we move the beads, like 2, what we want to do is we want to see what the 2 beads look like. Now the reason why is because it's super simple for us, right? Because we're adults. We know this. But the idea is to see the beads move and to also have muscle memory. So, Books by Bert, thank you for the follow. So we're going to do this number here. This number is 7, right? So I'm going to put 7 on the abacus. Can you see that? Yeah, 7 on the abacus, right? And then I have 2. So if annoyed middle child. I have a middle child, but he's not annoying. He's really quite smart. I feel sorry for whoever is. Anyways, so I'm adding 2. So the idea is to know that I'm adding these 2 beads. So when I add these 2 beads, my answer is 9. That's all I'm doing. I'm only moving the beads to make my answer. That's the only thing I'm doing. But notice I am looking at the add-in to figure out what I'm trying to do. I'm trying to add in 2. So if I have 6, I want to add 2 beads. So that was the one thing I remember is I was doing some research on how to teach children, and what do other people do? Because my kids, when they were going through abacus, I didn't have to help them with math at school because they already knew how to do the abacus. Did they get confused? No, they didn't get confused. They just got annoyed because, oh, thank you so much for the likes. They just got annoyed because they had to show their work. And in abacus, we don't show our work. We just do the numbers. Hey, Ethan, welcome. Thank you so much. Thank you so much for the likes. Okay, So what we're doing is what we want to do is we want to know what the process is, right? But I noticed in the earlier stages in when we do kindergarten and we do first grade and all this and that, we focus on the result, and that's not something that Abacus does. So what do I mean? Well, the one of the question was 5 plus 3. So we do 5 plus 3. We're going to do 5 plus 3. So if you notice, I add the 5. I'm going to start here because I feel kind of crazy. I'm going to start here. Because you can start at any dot, but I'm going to start here just because. So I want to add the 5. And notice I have enough to add the 3. So I'm going to add the 3. My answer is 8. And then the people in the video were like, yeah, 3 or 8. That's great. We know what 8 is. And I was like, okay. Okay. And then the next question was 7 plus 1. So we have 1. So notice I have my 7 and I add the 1. So I'm going to add the 1. And then again, they were like, yeah, just learned this so fast thanks to you. Yeah, I'm telling you, simple to use, easy to remember. So we're back to here, right? So then again, they were really focused on the answer. Yeah, this is 8. This is fantastic. Now, the one problem is that the last question was 4 plus 4. Now, why is this a problem? This is a big problem because now when you look at in the abacus, we have 4, and now I need to add another 4. I'm like, what am I going to do? What am I going to do? Well, we know this thing called making of the 5. In school, we're teaching children how to make a 5, and that's the greatest thing because it's a concept that we can use in Abacus. Now, why are we using this? This concept that we're using is called making of a 5. Okay, in the chat, how many ways can you make a 5? Please put in the chat, how many ways do you think you can make a 5? Making a 5. For example, right, 0 plus 5. 0 plus 5 is making a 5. In the chat, please put in, how do you make another 5? What's another way to make a 5? Let's talk about this. Let's have a conversation. Let's discuss about it. Thank you, thank you, Roman. Thank you, Ethan. So we have 5 plus 5 is not equal to 5. 5 plus 5 is equal to 10. Lady E, yes. So we have 1 plus 4 is equal to 5. And then Roman said 5 plus 1, right? 4 plus 1 is equal to 5. We know this. This is great. This is fantastic, right? Oh, yeah. Thank you, Brenda. 2 plus 3, right? And then the opposite is 3 plus 2. This is, again, a concept, making of the 5 that kids are learning, right? We know this. Not a problem. So now what? Well, if you notice, we don't have any more beads to add the 4. What are we going to do? Thank you, Mal. What we're going to do is we're going to take the 4. We're going to take this 4 and we're going to utilize it. We're going to isolate this variable. We're going to take this 4 and we're going to isolate the variable. How do I isolate the variable? To isolate the variable, I am going to move this 1 to the other side of the equation, right? So what does that mean? So now I'm utilizing it. I'm making it into a number sentence that I can use. So I'm going to say plus the 4 is equal to plus the 5 minus 1. Remember, this is how we made the 5. Now we're going to utilize it. We're going to make it work like it's supposed to, right? So what does that mean? Well, I have my 4. I want to add another 4. To add another 4, all I got to do is plus the 5 and minus the 1. So all I have to do is plus the 5 and minus the 1. And that's it. Boom. That's it. So if you notice, we in Abacus, in the world of Abacus, if you come follow with me, we don't learn our doubles. What we learn is the number we're trying to add. We learn how to use the add-in. So when we use the add-in, we can use it anywhere. It just doesn't matter what we do now. In school, when we had to learn our doubles, we did doubles plus 1 or doubles minus 1. But in Abacus, we don't do doubles. What we do is we do plus the 4 is equal to plus the 5 minus 1. We remember this, and it becomes with us. It is now ingrained into our brain. Plus the 4 is equal to plus the 5 minus 1. Why? Because that's a fundamental concept that is the groundwork for all Abacus. Thank you for the follow, B. Okay, so let's take it one more step, right? So let's take it another step. Let's do this one. Let's do 3, right? Easy, right? 3. And then we're going to plus the 4. Well, we don't have any beads to plus the 4. What do? We go back to our formula. This is our formula. This is an abacus formula. There's many names for it. It can be called small friends. It can be called friends. It can be called plus 5. In the mainstream school, it would probably be something like how to make a 5. Thank you for the follow. So we know this. Plus the 4 is equal to plus the 5 minus 1. So all I got to do is plus the 4 plus the 5 minus the 1. And the number is 7. How do I know it's 7? Because if the top beat is 5, so it's 5, 6, 7. So now we have 7. Make sense? Are we okay? See? Nobody's dumb in this room. Come on. Simple to use, easy to remember. Oh, Dandelion, thank you so much for the hearts. Do you always take away an abacus? Do you always take away an abacus? Yes, you always do a takeaway. If you add, you have to subtract. So I only see user 110018. So okay, that's okay. So what we're going to do is we're going to count. So the first thing we're going to do is we're going to understand how to read the abacus. So before we go forward to doing the adding and subtracting, we need to understand how to read. So to understand how to read, we're going to do 1, 2, 3, 4. Just like a die, right? We have a die. This is 4. This is 4. See that? 4 and 4. Oh, yeah. So somebody was telling me that when I do 5, it's like a tally mark. I get how to read the abacus. Oh, okay, good. Okay, good. So then we're back to here. So what we want to do is when we make a 5, right? Thank you so much for letting me know. Okay, so when we make a 5, what we're going to do is we are going to have a 4, right? We want to add the 4. The question is 4 plus 4. So when I see my abacus and I want to add the 4, I'm going to plus another 4. So notice I don't have enough beads to plus the 4. So what do? So then I know here I need to plus the 4 is equal to plus the 5 minus 1. That's all I got to do. So I'm going to plus the 5 and then I take away the 1. So then my answer is 8. Did that make sense? That's it. That's all. But we have to memorize the formula. When we memorize the formula, I mean, there's other formulas, right? The other formulas is the same. So I have a plus the 1 is equal to plus the 5 minus 4. And then again, I have the 2's and the 3's, right? Plus 2 is equal to plus 5 minus 3. Plus 3 is equal to plus the 5 minus 2. So, user, that's all I got. I don't know. It didn't convert your username yet. So user 188, what was it that you were a little bit confused about? Was I going a little bit too fast? Because sometimes I do that. So here's another question. Let's do another question, right? Let's do 2. So 2 plus 4 plus 4, right? When we do that, it's the same thing. So we have 2, and notice I don't have enough beads to plus the 4. So what do? I have to start using this formula. That was one of the things. That's one of the principles. The principles is if I don't have enough beads, how can I add the 4? So if I can add the 4, I will plus the 5 and then take away the 1. So Brenda, I'm not sure the question. Do you always take away an abacus? No, I was confused how to change the formal for different numbers. Can you do yes, so 7. So no, I was confused how to change the former. Oh, how to isolate the variable? So isolating the variable, we just memorized the formula. Oh, okay, good. Thank you. Okay, so the question is 4 like the bead. Every time you add a 4, you remove a bead. Yes. So you will notice that there's a pattern. When I add the 4 and take away the 4, you'll notice that this is a pattern because we're utilizing the concept of 5. So Shani says 4 plus 3 plus 5 minus 8. Minus 8. There we go. So this will be easy. This will be easy. Why? Because we have 4 right? And then plus 3. We don't have enough beads to plus the 3. What do? This is it here. Plus the 3 is plus the 5 minus the 2. So we have to plus the 5 and then take away the 2. Now we have to plus the 5. To plus the 5, it's called making a 10. When we make a 10, the concept's the same, but now we're doing with a 10. So the formula that we have to memorize is plus the 5 is equal to plus the 10 minus 5. This is another formula that we have to memorize. So what we're doing is we're adding the 5. So the formula is plus the 10 minus the 5. And then we take away the 8. Take away the 8 is again another formula. Minus the 8 is equal to minus the 10 plus the 2. This is again another formula that we have to remember. If we know how to do the plus, we have to do the minus. So we have to take away the 10 and then plus the 2. So my answer is 4. So like the bead, every time you add the 4. Yes. So so Brenda, if we have to use a formula, we will always do an adding and a taking away no matter what, because it has to go hand in hand. So if you see, this is my one formula, plus the 5 is equal to plus the 10 minus the 5. So I plus the 10 and I took away the 5. So yes, that's what it was. That was helpful. Oh, good. Do you ever get a negative number? You might get a negative number, but typically you don't, because you can't get a negative number out of a physical object. You could finagle it, but it would get messy really quick. Because when the numbers get more, like you get a lot of these numbers, let's say we had a negative here, so 4 minus 8, and then you have to keep in your head, you have to minus the 4, right? It gets really messy. So I would not recommend saying yes. I would not have a negative sign. But you can do division, you can do the decimal, and you can do multiplication on it. So yeah, that's a common question about, do I get a negative number? And no. When you get negative, it gets kind of wonky, because then you have to, yeah. Okay, good. Okay, good, user. Can you do a division problem? Yeah, I could do a division problem. If we're ready. Are we ready? We're ready. We're so ready. Okay, good. So, yeah, great. Let's do a division problem. Thank you so much, Shani, for the questions. Okay, anybody have any more questions? We can do a division problem. Let's do a division problem. Let me find one. Let's see. Boom, 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 boom. Okay. We'll do this one. Okay. 2, 5, 2, 4, 6. Now, there's a few rules that we need to do. One of the rules is to figure out where our starting point is. When we know where our starting point is, so this is a division problem. When we know where our starting point is, then we know where we're going to put our abacus. We know where we're going to put our number. Excuse me. Okay. But I'm going to use a different abacus because I ran out of beads the last time. So I'm going to use the bigger abacus because I have a lot more columns. All right. So the first thing we're going to do is we're going to do a find our starting point. We're going to find our starting point. To do that, we're going to take our dividends. We have 4 dividends, right? We have 4 digits in our dividends, and then we have 1 divisor. So in our dividends, and I'm going to call it E, we have 4 dividends. We have 4 digits in our dividend. So what we're going to do is we're going to take away the amount of digits with our divisor. I'm going to make this S, because dividend and divisors sounds very similar. So we could say E and S. So S, our divisor is 1 digit. So what we're going to do is we're going to start at the 3rd column. So we're going to start at the 3rd column because that's how we know where we're going to put our answer. 1, 2, 3. So we're going to start at the hundreds column. So when we start at the hundreds column, now I need to set my dividend on my abacus because we're going to start subtracting. So just like how we do long division, but we do it on the abacus. So 5, 2, 4, 6. Now we're going to have a conversation with our numbers. we should have a conversation with our numbers because we want to make sure that we're all on the same page. So the first thing we're going to do is we are going to figure out and compare who is bigger, the dividend or the divisor. The dividend is the only, we're only looking at the first number. I keep moving it. We're only looking at the first number. We're only looking at the 5. We're not looking at anything else. We need to compare who is bigger, 5 or 2. So put in the comment which one you think is bigger. That's easy to do, right? I need to move my stuff. So, oh, did I mess it up? I hope I didn't mess it up. Let's see. So we did 1, 2, 3. So we have 5, 2, 4, 6, right? So, yes, 5. Yes, thank you. So the 5, the E, 5, the dividend is more. So when the dividend is more, we only need to use one column, and we're going to skip this column. This is a rule that we need to remember because now we're doing division. This is assuming that everybody knows how to do adding and subtracting, and this is assuming that we all know how to multiply, right? So because the dividend is bigger, I'm going to use one column and I'm going to skip one column. Okay, so I'm going to skip this column and I'm going to subtract this one column. So now my question is what times 2 is equal to 5 or less? We have to say less because we can't take away from a bigger number, right? So 2, exactly. So 2 times 2 is equal to 4. So I'm going to put 2 in my answer. This is my 2. This is my answer. Now I'm going to take away 4. Do I have enough to take away 4? No. To take away the 4 is equal to minus the 5 plus the 1. So I'm going to minus the 5 plus the 1. All right, great. We're done? No, we're not done. Why? Because we have partial quotient. So with our partial quotient, now instead of looking at this number here that says 2, we actually have to look at our dividend that's on our abacus because we only want to look at the first column, our first digit. So notice now our digit is 1. So our dividend is 1. Our divisor is 2. Thank you, Ethan. Our divisor is now bigger. When the divisor is big, we need to use 2 columns. Again, this is where this is another rule. So because my divisor is bigger, I'm going to take 2 columns. I'm going to use these 2 columns. Use these 2 columns to figure out my question. So what's the question? 2 times what is equal to 12 or less? Ooh, sorry. I just wrote the answer. So 6, right? Take away 1, take away 2. Okay, we're done. Are we done? No, we're not done. Why? Because we still have a partial quotient. So what's next? We got to look at our partial quotient and we got to take a look. I keep moving it. Sorry. So 2 is our divisor. Our dividend is 4. I got to change colors. Who is bigger? Our divisor or dividend? Who is bigger? Yes, thank you. So our dividend is bigger. So when our dividend is bigger, we're only going to use one column and we're going to skip one column. So we're going to use this column and we're going to skip this column. So our answer is going to be right here. So the question is, what times 2 is equal to 4 or less? 2 times 2 is equal to 4. I add my 2 here and I take away 4. So again, my question is, I still have a partial quotient. My 2, what do? I have to compare 2 or 6. Thank you, everybody. Right? Who is bigger now? 6. 6 is bigger. Thank you. So 6 is bigger. Again, I skip one column and I only take away one column. So the question is 6 times what is equal to 2 times what is equal to 6 or less? Thank you, user. 2 times 3 is equal to 6. So I take away 6. So then my answer, okay, who can read my answer? What's my answer? Anisha. Welcome. 2,623. Exactly. Hey, Brittany. Welcome. Make sense? So that's division. Anybody have any questions? Did I go too fast? Oh, sorry. A little late. Okay. So does that make sense? Anybody have any questions? Was it okay? Was I talking too fast? Okay. We're going to continue on. Should I go back to adding or should I go? I mean, I saw you do it, but I can't say it made sense. Okay. So I think what it is sometimes I talk too fast. So we could do it again if you want to do it again, or do you want to do another? Do you want to do another question? You're good, but I think I have to watch it a few times. Yeah. So we do a same one, or we do a new one. What do we want to do? We're gonna do a new one, or we're gonna do the same one. It was the columns and the going back and forth between dividing and subtracting something. Yeah, new. Okay. Yeah. See, that's the thing, right? Like, don't forget, Dandelion. The questions for the kids doing division, they do division like the second or third year after Abacus. Okay, Shani, we'll do a new one. So the problem is, what's the problem? The problem is we're trying to fast track everything, but we really need to know the groundwork on subtracting. See, like, obviously for me, it makes sense because I know what I'm trying to do, right? But because this is still very new, it's hard to add and subtract and divide and multiply all at the same time and to figure out where we're going. Okay, so let's try a different one. Let's try this one. I'm using the lower numbers so we can keep up. So here's the other question. Let's do it this way. 3,201, divide that by 3. Okay, so again, we're going to find our starting point. I'm going to have to watch you do it maybe 20 times for the pattern recognition to send it. Yeah! I have plenty of questions. Yes, I will have plenty of questions. As long as you're okay, I'm okay if you're okay. So what are we going to do? We are going to do it again. We're going to find our starting point. So our starting point is 4 take away 1, right? Our dividend, see now I'm changing it up a little bit, right? Our dividend is over here, and our divisor is over here. So our dividend is 4, and our divisor is 1. So where am I going to start? I'm going to start at the hundreds. So I go 1, 2, 3. This is my hundreds. I always forget the step. I need to put my dividend on my abacus so I can subtract. So I have 3,021. So before I do that, and then the next thing I'm going to do is I'm going to set up my chart because it's easier for me to see. And I can't be bothered to memorize things because I'm getting old and getting kind of tired of this, right? I don't need to memorize. That's BS. Anyways, sorry. So now what I'm going to do is I'm going to change color and I'm going to compare. My divisor is 3, and then my dividend is 3. Whoa! All right, we could do it. We could do it. We could do it. You know how we can do it? Oh boy, we're going to do it. What do we do? Well, now they're equal. That's the wrong question. But now we go. Okay. What happens? You got to go to the next one. I got to change my color. You got to go to the next one. That means you got to go to this one. There's a 0 here and there's a 0 here, right? We're going to pretend that there's a 0 there. Now what? They're still the same. What are we going to do? We got to go to the next one. So we got to go here. There's a 0 here and then there's a 2 here. So now we know that the dividend is bigger. So we got to do that. This is just one of those situations that you need to recognize. So because they're the same, you got to go to the next number till they're different. And then that's the number you compare. Hey, Aiden. So we know that the dividend is bigger. That's how I know, because after the third digit, it's a 2. We're okay? We're tracking? That's okay? All right. So what we're going to do is, because the dividend is bigger, it is 1 column. So we're going to skip 1 column and we're going to take away this 1 column. So the question is 3 times what is equal to 3 or less? 3 times 1. So I'm going to add my 1. And then I take away the 3. Thank you, user. Thank you, Ethan. Yeah, it still tells me that you're a user. I was like, okay. Okay. So we're done, right? No, because we still have a partial quotient. We still have some stuff to do. But instead of going back to the question that we're writing, we go here. The question is, who is bigger? I'm only going to be taking the first digit of my partial quotient, and that's 2. My divisor is still 3. So who is bigger? Three is still bigger. Oh, okay, yeah, 3 is bigger. So what's going to happen? That means I'm going to put my finger here, and I need to take away 2 columns. Yes, the divisor is bigger. Thank you, Dandelion. So I'm going to take 2 columns. So these 2 columns is 21. So my question is 3 times what is equal to 21 or less? 3 times 7 is take away 20, take away 1. Thank you. That's exactly what it is, user. So then who can read my answer? Thank you. Yes, exactly. The answer is 1007. You're right, Ethan. You're right, user. Make sense? Hey, Tansin. Make sense? Why do you put 7 in that column? Because we are next to the dividend. That's why. That's the only reason why. That's a rule that we have. That's why we put it in the next column. Because remember, our dividend was over here. Because our dividend's over here, we're taking these 2, and that's what it is. If our dividend was bigger, if our dividend was bigger, then we would skip this column and go over here. So the reason why we have our dividends here is to also help us track where we're going to put our answer. The hard part is to know where to start each part. To start each part always goes to wherever your dividends is. That's why you use the dividends to help you track it. So when we were doing it, let's do another one. 720 divided by 6. Our starting point is 1, 2, 3, 4. 3 take away 1 is equal to 2. We're going to do it again. But notice where I put my dividends, right? It's the dividends is the key to know where to put your answers. So 1, 2, right? Because it's 2. So my answer is going to be here. I'm going to use my dividend. I'm going to put my dividends here. 720. So now, who is bigger, my dividend or my divisor? Oh, that's an E. My dividend or my divisor? My divisor is 6. My dividend is 7, right? I got to change a different color. So, because my dividend is bigger, right? Yes, my dividend is bigger. Yes, my 7 is bigger, right? Notice where my dividends are. So my dividends are here. My answer, I need to skip this one column because my dividend is bigger. This is a rule that we need to know. Because I skip one column and I'm only taking one column. Why? Just like when we do in long division, 6, 7, 2, 0. How do you know to just to use the 7, right? So in Abacus, we do a comparison, and this is a rule that we do. If the dividend is bigger, then we always skip one column and we only take one column. We only subtract one column. In math, in mainstream math, we don't do this. In mainstream math, we're saying, okay, how many times does 6 go into 72? And we would have to calculate it out. So the reason why I like Abacus more is because we break it down into smaller chunks. We break it down into smaller chunks. So now, it's confusing in the beginning because it's a new way of thinking. It's a different way of thinking. But we actually do is we break it down, we decompose our question. So now the question is, what times 6 is equal to 7 or less? Oh, hi, good night. Good night, Hockey. So 6 times 1, so I put my 1 here. My answer is 1. My answer is 1. And then I'm over here, and I have to take away 6. So just like I did here, right? I take away the 6. So my answer is 1. Hey, thank you so much for sharing my life, Sophia. Does that make sense? So my I don't know how I keep moving it up, but okay. So if you notice, my 1 is over here. That's where this is. We're in long division. We're 1. Okay? But the thing is we have it on our abacus. So now the question is who is bigger? Our divisor or our divisor or our dividend? Is the divisor bigger or the dividend? The divisor's bigger. So what do? We bring down the 2, which means we're going to take these 2 columns. Because we're taking these 2 columns, where does the answer go? The answer goes next to it. Just like our answer will go right here. Yes, the divisor is bigger. So the question is 6 times what is equal to 12 or less? 6 times 2. Yes, thank you, user. So we add the 2 and we take away 12. Take away 1, take away 2. So just like here, we add the 2 because we bring down the 2 and we know that 2 times 12 is... So our answer, don't forget to bring up your 0 here. We don't need to worry about the 0 because the abacus keeps it for us. Make sense? Yeah. Yeah. Okay, great. Yeah, I think sometimes it's helpful to show what we do in long division and compare it to what we do in abacus. What do you mean by keeps the 0? Well, it's right here. That's where our 0 is. This one, right? We did this. We brought down the 2 with my messy handwriting. And then there's a 0 that goes all the way down. So 6 times 0 is 0. So our 0 is here. When we keep the 0, that was just a thing. I don't need to worry about the 0 because it's already here for me. Because I've already divided everything out, I don't need to worry about it. The questions is nice because there's a zero, there's it divides out evenly. So that's what I mean. There is just a zero here. I don't need to do 6 times 0 is 0. That's what that means. So, did that make sense? Whew. Thank you so much for the hearts. Wow, 4,000. Okay. You want to do another one? Yeah. It's yeah, again, it's a little much. Okay, good. Don't forget, it's a little much, but don't forget there's like we've done like assuming you've done like all 10 stages, we're now up here. You know what I mean? Like usually we start down here and then we work our way up. But everybody's asking is like, okay, let's do it. So a lot of it is also understanding how to add and subtract. So let's do another one. Because we cool like that. I just need more paper. I just need more paper. Okay, great. So the question is, let's see. The question is, that made sense. That made more sense. I'm going to have to see it 19 more times. Have a good night. I learned how to use this math. Yes, fantastic. Have a good night, Johnny. Dandelion. All right. So the next question is, we'll do it this way. 2. Thank you so much for the follow. 3124. Let me see if I can write it. Let me see if I can make it more straight, right? All right. So again, what is our starting point? Our starting point is 3. How do I know? Because there's 4 digits here and 1 digit here, right? So 4 take away 1 is equal to 3. So I'm going to put in my abacus. I'm going to go to 3. I usually count this as 1. 1, 2, 3. So I'm at the hundreds. Because I'm at the hundreds, now this is where I'm going to add my answer. So what I'm going to do is I'm going to put my dividends here. 3, 1, 2, 4. And then I'm going to label because I don't want to, I get confused easily. So now I have my chart, right? S and E. Now I compare dividend or divisor. Dividend is 3. Divisor is 2. So, E, right, is bigger. Because the dividend is bigger, this is 1 column. Yes, thank you, user. Right? This is 1 column. So we're going to skip this column, and then we're going to only take this column right here. So the question is, 2 times what is equal to 3 or less? Hey, Yusuf. 1. Right. Because 2 times 1 is equal to 2. So I'm going to my 1. So notice I add my 1 here. I'm at my 1. I take away 2. I take away 2. And I'm now left with 1, 1, 2, 4. So my question is, who is bigger? Who is bigger? My dividend is 1. My divisor is 2. If my dividend is bigger, then I stay here, right? If my divisor is bigger, like this, because it is, then I have to bring down the 1, right? I bring this down. So then my question is 2 times what is equal to 11 or less? Thank you. Thank you, user. 2 times 5, thank you, Nat. 2 times 5 is equal to 10. So I'm going to add my 5 here, and I take away 10. Take away 1, take away 0. So I take away 1. Okay, so again, I have partial quotient still, right? I still have something. So my dividend is 1. My divisor is 2. So what did I just do here? Oh, I need another color. Let's see. So I did 10, right? And now my answer is 1. So again, my answer is dividend or divisor. Dividend or divisor. My divisor is bigger, right? So I got to bring down this 2. That's what I have here. I bring down the 2. So I have these 2 that I have to worry about, right? So who's bigger? My 2 is bigger. So the question is 2 times what is equal to 12 or less? I'm running out of color. Maybe I do red. Okay. So 2 times 6. Thank you, user. 2 times 6 is equal to 12. So what did I do here? I did the 5 here, and then I got to do 2 times 6, right? 2 times 6 is equal to 12. Take away 1, take away 2. All right. So now I still have partial quotient. I still have a partial quotient. So the question is who is bigger? 4, right, is my dividend, and my 2 is my divisor. My dividend is bigger. Yes, the 4 is bigger. So if the 4 is bigger, I know I have to skip this column. And I'm going to go here. So I skip this column. So what happens is 2 times what is equal to 4 or less. My abacus looks different from yours. Why? What does your abacus look like? So going back to here, my answer is 2. And then I take away 4. Yes, right? Take away 4. So then that's my answer. Jay, does your abacus look like 2 beads on top and 5 beads on the bottom? I don't know what happened. I don't know what happened to it. Yes, user. 1562. Jay, what does your abacus look like? That doesn't. Oh, there it is. So does the division make sense? Yeah. It has 10 rows with 10 beads on each and extra. Woo! It has 10 rows with 10 beads each and an extra one for each, so 11 beads on each row. Wow! I've never heard of that one before. I thought it would be something different. Could it be a Reckon Rec? Or is it a Kramer abacus? No, it's not a Kramer abacus. Is it a Reckon Rec? Or is it a smart right abacus? That doesn't make sense to me. I'm sorry, Jay. I've never heard of that before. And it goes across, right? I'm assuming that it goes across like this. Yeah, that is very different. How do you spell a Reckon Rec? Rec. I think it's Reckon Rec. I think that's how you spell it. Reckon Rec. It's a Dutch. It's a Dutch abacus, but it's red beads. What color are your beads? It's red beads on one side, so it's red on one side. One, two. There's 5 of them. 1, 2, 3, 4, 5. Right? There's 5 red beads, and then 5 white beads. 1, 2, 3, 4, 5. Yeah. Top row is red. Oh, okay. So if the top rows are red, then it might be the Russian one. And I didn't know it had 11 beads for good measure. It sounds like that it's all the columns of all the top beads is one color, and then the second bead is one color, and it goes across, right, like this, right? The bottom row is purple beads. Yeah, I think it's a Russian one. It sounds like it's a Russian one, and that would be a lot of just trying to more quantity based. The abacus, the Japanese abacus, is more place value. Do you know how to use your abacus, Jay? I don't think, I'm trying to figure it out. I just bought it. Oh, oh, where did you, okay, you know what? Where did you buy it? Let me see if I can look it up. Yeah, where did you buy it? Let me see if I can look it up. At Target. Oh, okay. I don't, let me see. Let me, Target. All right. Oh, you know what? Here. Um, Target. Um, is it a counting toy gigglescape? Baby and toddler learning. Let me see. I don't even know if I could share my screen. I can't share my screen. Oh, you know, I can. I can do it. I can do it. Do I do it here? It's a different screen, so it's different scene, and I gotta go this one? Yeah. So, this one? Does it look like that? Yeah. Oh, this is not a. Okay. Whew. This one is usually for trying to figure out. Um, what is it trying to figure out? I don't know. It's trying to figure out like numbers. So it's more quantity. It's a counting toy. They're all toys, really. um, I don't think you would use the 11th one is to make it look pretty, and you can still use it, but you wouldn't be using it for formulas. So the closest thing I could show you would be something like these blocks. So the closest thing I can show you with these blocks, right? So the idea is, I used to, it is used to count. Yes, exactly. It's used to count one by one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's a way to do multiplication on it. You can look it up. There's a couple of people that use that abacus to do more things. I don't teach it. So they were talking about, yeah, it's a lot about one to one. But I mean, as much 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm assuming it's for your child, and I'm assuming your child is young. You would use it as counting 1, 2, 3, 4. And you would and it just make sure that they understand the difference. That's it. So, no. It is an abacus. An abacus just means that it's a frame with beads. That's what an abacus is. So you do have an abacus. That's not wrong. It's just a different type of abacus. So we have a Chinese abacus. So this is a Chinese abacus. It has 2 beads on top and 5 beads on the bottom. We have a Japanese abacus is what I'm working on, and what I've been that's what I teach on, is the Japanese abacus. What you have is a something like a Russian abacus, where it's kind of all across, and you use it as a one to one. And what an abacus is, it's a counting tool. So did you ever see the movie Wonka? There is a character. There's a character. You know what his name is? No, his name is Abacus Crunch. Let me see if I can find it for you. It looks like here. That's what it is. Can you see that? And this right here, that's the abacus that you have. So it's true. It's not like it's wrong. It's still an abacus. I don't know if you can see that. But that's what it is. But if you want to do like yeah, yeah. What am I trying to say? You have to go search on the YouTube to see if anybody else. It's just different. Yeah, we're you have to go you have to go to, there's people that do count and use that abacus, and they show you how to use it. I'm just not that person. Sorry. But yeah, it is an abacus. It's not it. They're all toys. It just depends on what you want to do with it too. Like if you wanted to do like my oh yeah, no problem. If you want to do like my type of adding and subtracting, I and you could what you could you just have to finagle it a little bit because we have like our top bead. Okay, so our top bead is a value of 5 and our bottom bead is a value of 4. Sorry, value of 1. So when you put it together, that's 9. That's 6. So this is 6, 7, 8, and 9. Yeah, no problem, Jay. Yeah, I wish I could help, but I don't know that abacus. But you could finagle yours, and you could put it away. So, but yeah, I mean it's great for the beginning parts, right? To do the 1-to-1. You just have to adjust your formula. Yeah. You just have to adjust your formula, or you just have to adjust the abacus itself. So like this one is a Chinese abacus, and so with a Chinese abacus, it's a problem because oh my gosh, my camera. So in a Chinese abacus, it's similar to a Japanese abacus, but let me see if I can get it better. Okay. So here in comparison, this is just to compare, right? So this is a Chinese abacus, this is a Japanese abacus, and Japanese made it more efficient. Why? Because in the Chinese abacus, we have 1, 2, 3, 4, 5, right? This is 5. Where on the Japanese abacus, this is 5, and this will always be 5. However, this is also 5. Now, it's not a huge problem, but now in my brain, I have to remember 2 ways to make a 5, right? There's 2 ways to make a 5. But 6 is still the same. So that's 6 and that's 6. 7, 8, 9, and then there's 10. Japanese abacus, it makes sense because this is a 1-to-1. So this is the ones, this is the tens. So this will always be tens, no matter what. Whatever, if my ones are here, my tens will always be here. The problem with this is now it doesn't make sense because now this is 10, right? Because it's no longer using my columns as a place value. It's just, this is it. This is just 10. Now the question is this is also 10. And then this is 10. So now we're using it proper, but there's 3 ways to do a 10. What am I trying to say? What I'm trying to say is if you wanted to makeshift the Chinese abacus to work like a Japanese abacus, that's what you would have to do. I don't know if Jay's still around, but that's what Jay would have to do. He would have to finagle it a little bit. So, all right. Whew. It is midnight for me. I'm not sure how everybody else is. You guys are really committed learning about math on Friday night. That's funny. That's really funny. I didn't think anybody would be interested in learning math on a Friday night. Hi, S. Thank you so much. Thank you so much for liking my life. Any other questions before I sign off? You guys are so silly. I thought I was silly. Wow, I'm pretty passionate about abacus, but you guys are like learning it and stuff. It's like, woo, this is interesting. Oh yeah, thank you. I do think it's interesting. Oh yeah, thank you. Oh, Jay, do you want to know? I don't know how. Like, do you understand how I use the abacus? I mean, you have any questions? Let me know. I can go in and start adding it for you. I don't know where you came in. That's why I'm asking. I will tune in again and watch more. Oh, okay, great. Yeah, I'm live. Okay. Yeah, if you have no more questions, let me if you have any other questions and anything about abacus, let me know. But yeah. Yeah, it doesn't hurt to start with what you have because then you get to see the beads move and you get to see the quantity. The reason why is because we push the children very quickly to learn the numbers, and numbers are very symbolic. And so it's interesting on how, just like how numbers are like alphabets, you by itself, it doesn't make sense. But it's a little bit low, like, so letters, right? By itself, the letters doesn't make sense. You have to put it into a word. Just like, but the difference with the symbols on numbers is we kind of know what the quantity is. We just don't know what the quantity is of. What am I trying to say? These are symbols. Numbers and alphabets are all symbols. And so we push the kids to really understand the symbols, but not understand the the concreteness of everything. So I'm supposed to be boycotting Amazon, but I really need an abacus. you could you could get it from you could get it from Target. um I sell I sell these ones, but I don't sell the bigger ones. You could try Temu. You could try Alibaba. You could try. You know what, Dandelion? There will be an abacus school close to you. Take a look and see if they will sell it to you. I don't know how much it would be. Don't take my word for it. They might sell you like this one for like $25. I don't know. It's up to you if you want to get it from them. Yeah. So there's Temu. I haven't tried Temu. I have seen abacus like this on TikTok Shop. If you want to try to TikTok Shop, I try to add it to my, but I don't know if how do I do the affiliates. I'm not sure how to do that. I'm still trying to figure that part out. So yeah, I seen it in the TikTok Shop, and they're all plastic now, so it doesn't really matter. And as long as it moves well, and usually it does, the beads move well. They're all plastic. I don't think you're gonna find one that's bamboo or wooden like mine's, but that it will be a while. Or it'd be more expensive. You could try Japan. If you ever go to Japan, you can see if you get one there. Those are your other choices. So that's the thing, right? That's the funny thing. Like abacus helps me understand. Like, if I want it, how do I get it? And that's the critical thinking that I think attributes to abacus thinking, because there's a whole framework. Like, how do I do it, and what do I do? So, all right. If there's any more questions, I think I'm going to sign off a little bit. Maybe in Chinatown. Maybe in Chinatown. Yeah, you know what? Maybe in Chinatown. But be careful though. Make sure it's a one bead and four beads, right? Not a two and one. But yeah, you should be able to find one. Yeah, yeah. Or maybe Daiso. I don't know if you have a Daiso around you. This one actually came from Daiso, and I think I got it for like $2 or something. Daiso should be around you. Yeah. But you could check the other Daisos. Not all Daisos carry it. What do you mean by one bead and four beads? Oh, okay. So what I mean is this. So here's the one bead on top and four beads on the bottom. If you notice, the Chinese abacus has two beads on top and five beads on the bottom. Yeah, Daiso. Not all Daiso carries it, so you might need to like do a little tour of all of the Daiso, because the one by my place doesn't have it, but my brother said the one down the street had it. So you kind of have to kind of like look around, if you're willing to do a Daiso tour, or you can even ask them. You know, ask them if they even have it come into thing. I think it was $2. I don't remember the last time we bought the abacus, because I don't buy it anymore. But yeah, yeah, Daiso would be the one, for sure. Actually, not for sure. I don't know if they have it in stock. But yeah, did that make sense, Jay? Like the different beads. So yeah, I, yeah. I wish I had a little bit of music. Yes, thank you. Oh yeah, not a problem. Um, did you get the? Now I'm really curious. Did you get the abacus for your child, or did you get it for you? How do you use that? Hi, Christian. Oh, hi, Christian. Let's see. You have a number, and it says 4245. To use this is a counting tool. So what we could do is we're going to count. So the first thing we're going to do is understand how to read it. Do you have a YouTube channel? Yes, I do. It's Lynette, Miss Lynette. It's in my bio. And so Andrea, hello. Christian, two. Oh yeah, no problem. Thank you. I appreciate that you're here. I hope it made sense. Oh, thank you. You too. Have a good night, user. I'm sorry. I don't see your username. It just says user 188 something. But have a good night, and I hope I see you soon. Thank you for the follow. I know you did follow, though. So, Christian, so we're going to count, right? This is how we count on the abacus. And to use it, we know that we're going to be here in the middle. The Y, because there's this label, there's a dot here. I don't know if you could see it. There's a label right there. And that label tells me that this is the ones place. So this ones place is 1, 2, 3, 4, and then 5, 6, 7, 8, 9. And then we have 10, just like how we write. So that's how we read it. And then we can go into, adding, subtracting, multiplication, division. And that's what this was. So. Excuse me. Jay, was that abacus for you? Or for your child? The one that you bought from Target. I'm just curious. It's just one of those things. Kind of confusing to me. Confusing. Well, whenever the beads are touching this horizontal bar, this is the thing that you need to really remember. So this horizontal bar is what tells me that the beads are being counted. So I would love to learn it. Yeah, that's what I'm here for. So when we are looking at this abacus, right now it's all being zeroed out. So when we count it, this is 1. How do I know it's 1? Because this one bead is touching the horizontal bar. This horizontal bar is what tells me that this bead is being counted. So if you look at the other columns, there's nothing, right? These are zeros. So we know we're here. Now the reason why we're here is because I have an indicator. This indicator, if you could see, has a dot. That dot tells me that this is my ones place. You could do others. You could be here, but then I'd get confused, right? So that's why I stick with the label. So with the label, right, with the dot, that tells me this is 1. Now I have 2, right? Just like on a die, that's 2, right? This is 2. This is 3. Just like on a die, that's 3. And then 4. So the idea here is to be able to subitize, right? To be able to look at it and see that it's 4. So when we understand that this is 4, well, the question is, well, I want to know what 5 is. I don't have a 5. Well, to do a 5, it's the top bead. The top bead always has a value of 5 no matter what. No matter what. This is 5, this is 5, this is 5, this is 5, this is 5. That's always going to be 5 no matter what. All of these will be 5. The difference is, if this is 5, then that's 5, but this is now 50. How do I know? Because there's a 0 here. So it's a 5 and a 0. So if I go back and I do that, this is 0, 0, 5. This is now, what number is this, Christian? I don't know if Christian's still here. What number would this be? If this is 0 and 0 and 5. So this is my 1s, my 10s, exactly 500, right? Easy to see? And this is 5,000. How do you add 5 and 5 to get 10? How will you add 5 to, well, on my Chinese abacus, I'll show you. No. So, Jay, this is 500. Jay, your question is a little, there's a formula that needs to happen. But before we go before we start talking about formulas, we have to start understanding how to read the abacus. So when I do this, we know what number that is. What number is that? If this is the value of 5 and this is the value of 1, putting it together, I feel like Russell Peters when he says that. Together, we can make some shirts. Yes, 6, exactly, 6. So we have 6, not 9, because this is 5, this is 6, and this is 7. Yes, thank you, Christian. So, Andrea, we're still here. When we do here, the top bead is a value of 5. and the bottom bead's a value of 2, 1 and 2. So if you look, 5 plus 2 is 7. And then this one, we have 5 plus 3 is 8. Yep, not a problem. Yep, we'll take it slow. 5, here is 9. So this is 9. When all the beads are touching like this is 9. When you have the time, can you do a division problem with a decimal answer? Yeah. So any column can just be 5 plus whatever bead at the bottom. Exactly. So if I did this, right? 5, 50, 6, 60. Columns don't have place value. No, columns do have place value because now we're at 60. This is 60, 70, 80, 90. User, I just see user as a, I don't see your username. So user 6, oh, sorry, hold on. Let me verify. I don't think I will have time to do division with the decimals. Not today, but it will be later, like in my next live. We did a little bit, but we only did a little bit of division. So this is 90, right? How do I know? Because this is my place value. My ones, my tens, my hundreds, my thousands, and my 10,000. So Jay says any column can be 5 plus whatever bead on the bottom. It can be, but it still is a place value. So this would be, so Christian's name has a 4, so it's 4,242. So Christian's name is 4,245. What are the two columns to the right of the ones column? Haha, decimals. So we have our tenths, and then we have our thousandths. I'll check your page to see if you maybe have an example. I have, if you check my posts, I have examples, but I don't think I did it with decimals. I know I did division, but I don't think I did it with decimals. If you want to, I'll do a future post on it. How about that? Send me a DM so I can remember, and I'll post a division question with decimals. Because the other one was, I wanted to post a question with a fraction. I was trying to do that, but then I kind of forgot. Okay, so tenths and hundreds. So then, like, if we were doing money, right, this would be $5.35. That's what that would be. Make sense? So we would write it out. So notice it would be, $5 and then 35. Notice that this decimal does not have a place value. So if it doesn't have a place value, that's why it sits between the two columns. Yeah. So the two columns are to the right of the cents. Yeah. It can be cents or it can be decimals, right? Why do I say that? Because this is a lot of cents. When in the 13 column one, I usually start in the middle. All of this is the decimals. Okay? Usually, right? So it can go as far as you want, but it depends on where you want the ones to be. So if I want my ones to be on this side, then I have a lot of decimals to use. If I wanted to have this side, then I have a lot of the bigger numbers, right? It goes all the way up to trillion. So it just depends on where your ones is. Just like here, if I had my ones over here, this would be my ones, this would be my tens. So then all of this would be my decimal. So it's not just these two, it depends on where your ones is. So anything to the right will be part of your decimal. Again, place values. So basically you can basically place a decimal on any column to have any, yes, exactly. Yes, as you can do as many, like, you know how like the banks, or even like tax, they give you the decimals of like 90. Remember like the 99 cent store? It was like the 99 cent store, and then there was 99 cents, 99 0.999. That's what this is. So your ones can be any dot. Yes, my ones can be any dot. It can be any label. How do I get 10? If I clear out my abacus, and if this is my ones, this will be my tens. That's it. This is 10. It's 1, 0. Just like how you typed it. 1 and 0. 1 and 0. Yeah. So, oh, thank you so much for the follow. Yeah, so this is 10. So when I count, right, I have my 20, 30, 40, and then I have 50. That's what my tens are. So when you get to 9, it rests to 0. It resets to 0. Yeah. So I have a 9, and then I have my 10. Yep. Yeah. Kind of resets to 0. Kind of makes sense. Because you can only do 9, right? You can only do 9 in any column. You can only do 9. Yeah. Okay, good. See? Simple to use, easy to understand. Yeah. But the thing is we all have to start from understanding how to read the abacus. And because this is not a common thing, it's difficult to understand what's going on. And so sometimes I know that I talk too fast if I'm like really excited. But now I've been live a little bit. Do you recommend any books? Sorry. Do you have any books you recommend for flash, hands-on, or mental arithmetic? Flash hands-on is something on the screen that does this. So you would be looking for a computer application, a website that does the flash hands-on, right? And I'm assuming that you know your multiplication division, right? Ethan's asked, "Can you teach us flash hands-on?" It's not. There's nothing to teach really. It's just a bunch of numbers that just flash. Mental arithmetic. To do mental arithmetic, you really what it is you would do a lot of math problems. So I don't know how. So user 653, the one that asked the question about the books and stuff. How much abacus do you know? And who are you looking for? Are you looking for your child, your students, your like? I need to understand where the questions are coming from. And what would it be for? So like, because if it's a child, right, and then you're trying to put them into competition abacus, then I would probably send them to an abacus school. But if it's for you and you just want it to be faster, then and you already know all of the abacus formulas, then you can just pick up any book and you can just go through it. So I don't know where the question really comes from. There's got to be more. To me, I feel like that I need more understanding. My child is reached. I don't know what KYU is. I would like to reinforce at home. I don't know what 2KYU is. I'm assuming the second year. Do you know if your child already knows plus 10 minus 10? And they did all the way to division and multiplication? How do you use it for math? Uh Hold on, Christian. I user 653. I don't know what 2KYU means. Um I'm not sure what that means. Yeah, we can use it for math. Right. Um, that's what I'm saying. Level 2 KYU, I don't know what they're doing in level 2. So, how many digits of adding and subtracting is your child? Um, I'm trying to think. The only thing I can think of is, I mean, I have a website. I have an app that does flash ends on, but it's not public. So you would have to be part of like the school and stuff. 3 digits mental arithmetic with 6 numbers. Yeah, okay. So your kids, what would I do in that situation? I would take all of his old stuff. I'm thinking, you know what? You know what I'd do? I would take all of his old questions. I would put it in a I would put it in a PowerPoint presentation. Each number, put it as a slide, and then you have it as a presentation, and then from there you can get him to do flash ends on. That's what I would do. Cuz I don't think, or you would have to do a search. You would have to do a search on flash ends on. I don't remember where I don't know if there's anything out there anymore. It's so far and few. So you could either do it yourself, which would be, I think that would be the quickest. Take all his old questions and put it in a PowerPoint presentation, one number, and then you have to do the presentation. You would flip it. That's what I would do, because he's so far ahead. I don't think you're going to find a flash ends on that will do what he does, because you're doing 3 digits with 6 numbers, right? Six lines. I don't know if you're gonna find that. Not. I'm assuming you're in. Yeah, I don't know. I don't know where you would find it. You would have to find like another, either a Japanese school that's been more digitized. Thanks. There are websites, but they're all in Japanese, which I don't understand. Yeah, that's what I was thinking. Like, it's in Japanese. Um, yeah. The only thing you can think of is put in a PowerPoint presentation. You do it yourself. That would probably be the quickest and easiest way. Um, yeah, there's a Flash Enzyme website in English. There is. I don't know where that would be. I don't. Yeah. I mean, I have my own app. I have my own application, but that's as far as it goes. And I don't. We don't really force the whole Flash Enzyme either, because again, that's more like competition. I'm not certified. If if that's the other thing. Because I know there's certifications for Abacus teachers and Abacus, but I didn't go for certification. Okay, what was the question? Oh, we're gonna do adding. We're do math. We'll be mathing right now. So the easiest one. Let's do the easy ones. So the easy ones would be something like this. This would be easy. So the way I have it, and I broke it up, is we have it by the add-ins. So the question is 5. So we have 5. I'm going to clear my abacus. I have 5. So I'm going to add 5. And then I have here to plus the 1. So all we're doing is 1. So we plus the 1. I've never seen a workbook like this. No, because I made it. This is my workbook. I created a workbook specifically for preschoolers because we don't have it in anywhere. So what I did was, and you can find it on Amazon, and that's my name. And what I notice is when we teach kids, they usually already know their numbers, and we just need to teach them how to read the abacus. But I took it one step back, and I'd be like, okay, let's teach the young kids, because I feel like it would be easier to teach the young kids to start off, because we show them manipulatives like this, right? We use like those blocks, like we use these blocks, right? So I'm like, well, if we use all these things for kids, why can't we use the abacus too? So that's why I built this book, and I'm actually in the process of making more books. So how young can they start? That's the earliest age you should. I have students that are as young as 3, because they are just learning to count, and so I use the abacus and to get them to recognize the numbers and the thing. How do you read an abacus? I used a different one when I was little. So user following you on YouTube. Oh, thank you so much. Andrea, just so you know, for like a schedule, I'm on I'm on YouTube live, scheduled 9 a.m. Pacific Standard Time. If you have any questions about Abacus or my workbooks or my classes. So yeah, how young can I start? I would suggest to start them at like 3 or 4, when they start getting into like just starting to learn how to count. That would be the youngest. I know before we would only start at 5, but I like to go down a little bit younger than that. So just search what flash ends on is. Yeah. So flash ends on is when they just flash the numbers. That's why I was saying you could put it in a PowerPoint presentation and you could flash the numbers. So you you can get one you can get one at Target for counting only. You know, that's the thing. Jay, I'm going to remember that for the forever. Oh yeah. So going back to here, the reason why I broke up this book to do the plus thumb up, was because I wanted the kids to focus on the added. When we teach in school, I notice we focus in on the result. And that's a problem, because then what we do is we actually backtrack and try to remember how we do the process. So in Abacus, we actually learn the add-ins, what we do with the numbers. So that's why it was broken up into +1 thumb up. Now, what does that mean? Well, I put it into the different scenarios. So here's 2. So I have 2, and then I have 1. So I want to show them that all I want to do is I want to add the 1 thumb up. That's all I want to do, right? And so that was the thing about this. So then the next one was they go through a few problems, right? They go through a few activities. So this one is like follow the boxes, and this is just adding 1. Then there's the next one, which is adding 2. And again, it's the same concept, right? But I'm just reinforcing what it would look like to add 2. So here's a question, 1, right? 1, and then +2. So I add the 2. It looks like we're counting, but we're not, because we're now adding the beads together. But of course, when we add, we have to subtract. So this one was, here's a little puzzle. They have to answer the puzzle, and then they find the answer on the puzzle piece. And then this is 3. Again, it's the same concept. If I have 5, then they add 3. So my answer is 8. See that? So in Abacus, we focus in on the process. We don't focus on the result. So we do 4, and then there's a color by number. And then after that, we do -1. So whenever we add, we have to minus, because now we're going to start going into, after we do this, what we call simple abacus, which means that we're only moving the beads. When we move the beads, that means there's no formulas involved. When we start learning formulas, we need to know how to add and subtract. And that was the earlier part of the live, where I was doing a formula on how to make a 5. And I thought that was really good. So we have a -1. So again, the thing is we have 2. I'm over here. We have 2. We're going to take away 1. So we take away the 1. I'm only taking away the 1 bead. That's all I'm doing. So the idea is to just see what are we trying to do, and to reinforce that we're taking away 1 bead or we're adding 1 bead. That's all we're doing. So if you notice, like this one, I have 3. I'm only going to take away 1. and I take away 1. Abacus should be standards in schools. Our schools would be so much better. Yes, I believe so too. But that's what one of my goal is trying to do. And I was actually building a workbook specifically for 4th grade. But again, so that was one of the things, like, how do I introduce Abacus to the regular school? And so one thing was to understand terminologies. And so I'm starting to understand, like, we do a lot of terminologies that we don't do in Abacus. And because your child has been in it for so long, you'll notice we talk about making a 5, right? The friends. They talk about friends, big friends and small friends. But in regular mainstream, we actually talk about it as making a 5, which is what we're going to do now. So after we learn how to minus the 1, we're going to go into, isn't 4th grade too late? 4th grade is not too late. It just depends on how it's being introduced, right? So that's the caveat. When we start looking at things, I mean, if you really think about it, is it too late for me to learn, or is it too late for everybody else to learn? No. It just depends on our mind, on how we want to do things, right? So when I learned Abacus, I was old. I was like 30 something, right? And I've been teaching Abacus for about 20 plus years. And so am I as fast as my kids? No. I'm not as fast as my kids, but I'm understanding a lot, right? And we use Abacus for other things. So this would be great for schools. It would be. I would just have to figure out how to, because the problem is not everybody, not all the teachers themselves have so much to learn, and putting another thing on their plate would be so difficult. So what I'm trying to do is trying to figure out how to make it as easy as possible for everybody to learn. So back to here is the minus the 1, right? So again, the idea was, when we learn how to add, we will learn how to subtract. So that's what we did here. And we go all the way to plus the 6, and we do minus the 6, and then plus the 9 and minus the 9. So that's what we're doing here. And I use the abacus because I just want them to see what it looks like. So then after that, we can go into making of a 5. And that's what the next book would be. Why? Because in school, we're teaching the kids how to make a 5, right? Can you guys tell me how many ways to make a 5? How do I make a 5? That's like that's a question that the kids will know. I think they're learning that in kindergarten, and they might be learning that in 1st grade. How do we make a 5? So the first thing we're going to do is we're going to make a 5. We have 4 plus 1 is equal to 5. There's an example for you. So what's another way to make a 5? Yes, that's another way to make a 5. What's another way to make a 5? 5 plus 0 is equal to 5. Yes, exactly. 2 plus 3 is equal to 5. And then the other way, right? We also do the reverse. We also do the other side, which is 1 plus 4 is equal to 5, right? And then the other way is 3 plus 2 is equal to 5, right? So these are concepts we're teaching the children, and that's as far as we go. Now in Abacus, we actually take it one step further. What does that mean? Well, if I do the question 3 plus 4, right? If I show you on my Abacus, I add the 3. I add my 3. Not a problem, right? But now the question is I want to add 4. I don't have any more beads to add the 4. If you notice, I don't have any more beads. I only have 1 bead. So then the question is how do I add a 4? Well, to add a 4, if you notice, it utilizes this formula. It utilizes this number sentence. And we actually change it to make it into a formula. So what we're going to do is we're going to isolate this variable. This is the variable we're going to isolate because it looks like this. So because it looks like this, we're going to isolate the variable. To isolate it, if you remember algebra, we isolate it. We take this information, we put it on the other side of the equation. I'm going to rewrite it. So it will look like Plus 4 is equal to plus 5 minus 1. Okay? We're okay? Is everybody tracking? Thank you, Ethan. If everybody understands, please put in plus the 5 minus 1 into the comments. If we're tracking, if we all make sense. If we don't, I have to go back. Ethan. I know it's you, Ethan. Yeah. So what are we trying to do? We're trying to take this 4. Thank you, Christian. Okay, good. So we're tracking, right? Jay, are you with me? Are we okay? So what we're going to do is we're going to take this 1 and we're going to move it to the other side of the equal sign, right? So now we rearranged it, and now this is a formula. This is a formula that we all have to remember. This is a formula that we have to memorize. This is what the kids will memorize. So what we're going to do is we're going to, move it to the other side. Yep, good. So what we're going to do, so we isolated this variable. We're going to substitute this into here. That's it. Plus the 5. So I added my 5. Let me see if I can do that. Plus the 5. And I take away the 1. And my answer is 7. Welcome, Sir Patrick. I'm so happy you're here. So, what did I just do? I just took a formula that we are teaching the kids and we modified it to a that's the process. That's the process. That's it. This is the only thing we need to memorize. We will only memorize this and this only. Well, among other things. The children needs to remember the process. The children will remember the formula, and it just happens to be the process. We will focus on the process, the precious process as well. Is it the same for Chinese abacus? Yes. Yeah, it is the same. It's kind of the same. There's a little bit more leeway in the Chinese abacus because there's more beads. But what it is now when we look at abacus, in abacus we focus on the process. So in abacus we focus the process. We don't focus on the result because the goal may be the same, but it's how we get there is different. Okay? So what does that mean? Okay, let's take a look at it. Let's reverse these. Okay? Hey, Ludi the Rascal. Oh, really? Good. So let's take it one step further. Let's reverse these. Let's see the difference, right? So if I have 4 and 3, it's the same answer. Well, it should be the same, right? No, because the process is different. I go back. Now remember, I add my 4. So I'm going to add my 4. Now my process is 3. So we have to manipulate or change or substitute the factors. Yes, exactly. And that's why the abacus helps. Because we can see it and we see the pattern and we know what we're doing, right? So these is a pattern, but as you go through, you will notice that there's a pattern. If I want to add a 4, I know I got to do this because I have a 5 to use. These are a lot of verbiage that I'm saying because these are very new things that we're doing. But when I look at it, I can just do that. And I know what I'm doing. Does that make sense? But I say it to verbalize what we're trying to do. So again, here's my 4. My 3, I want to add 3. I'm going to isolate this 3. I'm going to move this 2 to the other side of the equation. Now I'm going to rewrite the equation. When I rewrite it, we're going to say plus the 3, because that's what we're doing. We're trying to add the 3 is equal to plus 5 minus 2. I will say plus the 5 and minus the 2 to remind me that I want to add the 5 and then take away the 2. And my answer is 7. But see, there's a difference, right? The difference is the process. The difference is the add-in that we're trying to use. The add-in that we're trying to use. Now, if I want to use this anywhere else, I can. So let's do 3 plus 3, right? Abacus, we don't memorize our doubles. Abacus, we memorize, so two different methods, right? Two different formulas. Because there's a whole set. Just like, I don't know what I'm trying to say. There's a whole set. So plus the 4 is equal to plus the 5 minus 1. Plus 3 is equal to plus 5 minus 2. Plus 2 is equal to plus 5 minus 3. And plus 1 is equal to plus 5 minus 4. This is a set. It's not different methods. It's a set. So the next one, we'll do 3, right? We don't learn our doubles. We don't do doubles plus 1. We don't do doubles plus 2. What we do is we learn the plus 3. How do we add the 3? Just like we did here. Plus 3 is equal to plus the 5 minus 2. So now it's a little bit more versatile. Because it's more versatile, we can utilize our 3. Plus the 5 minus the 2. So my answer is 6. So Abacus is actually doing an algebraic equation in physical material form. Yes. Is it? No. Abacus is moving the beads. We algebraically put equations in our head to move the beads. The abacus itself is just keeping track of your numbers. In like, if you really want to bring it down to the bottom, like just boiling it down, abacus is just moving the beads. The algebraic equations happens in our head, and what is the process we're trying to do and what we're trying to accomplish. So that's why abacus is important, because we have these set formulas and we have set checklist to go through. So the question was, the very first question that if you heard, the very first question was, do I have enough? So if I have 3, do I have enough to add 4? No, I don't have enough to add 4. How can I add 4? See, how can I add 4? I feel like I'm doing an algorithm. You are. You are doing an algorithm. You're doing an algorithm. You're doing an algorithm. You're doing algebra, but not really. So it's funny. My kids actually started, he started algebra. And he's like, I don't know algebra, but I know it, and I don't know why. And I told him it's because we do these things in abacus, but we never label it. We never say substitute this in. We never say isolate the variable. Why? Because when kids are learning this, they're 5, right? They're 5, they're 6. They're not going to know what an isolate the variable is. What they're going to know is that they're going to know the formula. That's it. They don't need to know that we're moving the number to this side, because they don't care. How much time do your students study abacus each day? I recommend maybe 10, 15 minutes. I gotta go, Lynette. When are you live again so I can join? I am live often. You can follow me and get notified. If you want a specific, then it would be YouTube, 9 a.m. on Wednesdays. That's like specific, but I am live quite often on TikTok. That makes so much sense. Isolate variable is fancy smancy for saying move the beat. Yeah, exactly. Exactly. See, that's the funny thing. Like in abacus, we just say, you know what, just do this and you'll be fine. But in order to relate abacus to mainstream math, I need to find the vocabulary and the glossary terms. So some of them was like I was talking about the partial quotient and then the partial product. We never talk about that in abacus. It's just do the work. That's it. Oh, thank you so much for the follow. Thanks for teaching me something. Yeah, not a problem. Let me know if you have any questions about abacus. I'm happy to explain it. Yeah, so honestly, that's my thing for the kids to just understand abacus and to let them to be happy with math. And I don't want it to like, you got to go, day in and day out and just keep going. Because what's the point? For me, it was to get them to be comfortable with math and then to move them into complex math. Because abacus is the gateway to complex math. If they're comfortable with it, then I'm happy. I don't push them. I don't put them into competitions. You can. I don't. I tried, but it is what it is. So, I think for me, I just want the kids to be comfortable and understand to do certain things. So, like my kids, they were probably in first grade or second grade, and they already knew their multiplication table. So, because it's just part of the process, it's just part of understanding abacus, and so they have really good number sense. They have really good number fluency, and then they did algebra, and they were fine. They were great. They did Common Core. They were fine. They were great. Um, and then what we could do is we can work on like the number problems, the word problems, the other things. What organizations have competitions in SoCal? Not in SoCal. It's more international, like India. There's a couple of abacus competitions. I know in Northern California. There might be some in New York. I don't know. If that's where you want to go, I don't know. You would. There's an organization. There's an abacus organization, but I'm not a part of that. I think they're. Excuse me. I think they're Japanese based. Um, I haven't seen them. I don't know if they still have them now after COVID. I'm not sure. Um, I don't know. I can't say for sure. You would have to search it up because it's not something that I was thinking of putting my kids into it. So, good luck, user 653. Um, yeah. So, any other questions? Oh, that's what it's doing. Oh, so you might find this interesting. So if you know the five, we're making it the five, right? We make a five. Now we do is we minus the five. When we minus the five, it's the same thing, but now reverse. So we have minus four is equal to minus the five plus the one. It's the same thing. Because why? When we have eight, right? And we have to take away four. Notice I cannot take away four. There's not enough b's to take away the four. So what do? I minus the five plus the one. So I minus the 5 and I plus the 1. So my answer is 4. So again, we know plus 3, minus 3. The opposite of the opposite of plus 3 is minus the 3 is equal to minus the 5 plus the 2. And then we keep going. Minus 2 is equal to minus the 5 plus the 3. And then minus 1 is equal to minus the 5 plus the 4. So again, we go back to if we know the plus, we need to know the minus. And then that was the thing. One of my lives, somebody's called me Mrs. Miyagi, and I don't know if anybody has seen Karate Kid. In Karate Kid, we have to wax on, and then we have to wax off. So that's what this is. The plus 5 is waxing on, and then the minus 5 is waxing off. Looted rascal. I never knew how helpful abacus is. I feel like it would be made math easier to learn. Yes. Yes. It was so easy. When I started learning, it was like, oh my goodness, this is the greatest thing next to sliced bread. And and that's what I wanted. I wanted to be like it wanted to be more of a feel good kind of a thing, and just to be able to like move the beats to understand. So like, when we do a 7, right? And we plus the 4 when we want to add the 4. The question is I feel like I missed out. you know, I do too, but then I have kids and I live vicariously through my kids. So have some kids and then teach them abacus. But they're going to hate it. I'm not going to lie. My kids did not like Abacus whatsoever because they didn't understand what was the point. I mean, now they're older and they're like, oh, this makes sense. And they know and they do feel it, but it was a struggle for them to go through Abacus class. I'm not going to lie. Like, and that was the reason why I did these activities. Because the activities, I feel like, if they were a little bit more engaging, it wouldn't be so boring. So I made activities to help understand Abacus. And so I made this book specifically for Abacus. And there was another one too, and I made a plus 10. It's the same thing. I have it's not, but then again, it's not for competition. It's for just understanding and to get a more general idea. So I have it where they practice, but I don't push them to do like 2 hours at a time or 1 hour. I did when I was young. When we first started doing Abacus, I was like, oh, I would do that, but now it's like, no, I don't see the need for it. What would you recommend to use to learn the abacus? Do you sell the books? I do sell the books. It's on Amazon. My name, you can find my name. I have one for preschoolers. I'm working on an adult book. I'm working on an adult book because I didn't realize that there were so many adults that wanted to learn abacus. But this is the little series. So if you have a preschooler, this would be great for your preschooler. And then after preschool, there would be plus 5 and then plus 10s. Yeah. And then, yeah. So, no, thank you. Let me know if you have any questions. But I'm here. I'm on live. It was just one of those things like, it's just one of those things to try to make it more mainstream. So thank you for joining me. I do appreciate it. I don't know how old your child is or if you wanted to learn, but I am planning to make an adult one, and I was thinking about making one for parents to teach their kids, but I'm not really sure about that yet. And then I was told to try to make one for teenagers. So I would have to figure that one out too. So that's a little bit of a kind of thinking about the outlining on that. But again, I mean, it goes back to understanding the formulas. You understand the formulas, you wax on, and then you wax off. And then after making the fives, there's making of the 10. And that's what the other book is. You have to make a 10. But once you know that, then everything is gold. Anything that you do relies on making a 10 and making a 5. Yeah, not a problem. Let me know, Looted Rascal, any other questions you have about Abacus. But no, I appreciate all the comments and questions. But is there anything else? Any other specific questions? Any other burning questions you're asking? Oh, the books. Yeah, no problem, Jay. I just laugh at the Target abacus. It's still an abacus. I'm telling you. There was one. Somebody was actually going to make one. You can make one. It's up to you. Um, but yeah, if there's no other burning questions, I mean, let me know if you have any other abacus questions. I'm available to ask. Yeah, I will tell you whatever I have in my head. But yeah, but the competition ones, I'm sorry, I don't know. Um, but yeah, I think if the kids can do 10, 15 minutes of just math, I think we're okay. I think that would just be very helpful because you want, and if it's daily. Hi, Daddy Denny cooking. If you could do it daily, that would be great. But I know, like we all get busy. I remember when my kids were young. I mean, we all got busy, and as long as they did like 5 or 6 questions, then you're gold. Because you wanted to do is you wanted to keep it going to go from working memory to long term memory, and I think just doing that would be fine. But like I never pushed my kids to do flash ends on, and I never really pushed my kids to do mental math. Not with the abacus. It just got too hard. So okay, so if there's no other questions, I am going to sign off, and I will see everybody in my next live. If there's no other burning questions, um, let me know if you have any other questions. And then, but yeah. Jay, if you're around the area, if you have a Daiso, you might want to look into a Daiso if you're thinking about an abacus. My next live, you can follow me and get notified. If you want it to be like a specific time, I'm on YouTube at 9 a.m. Pacific Standard Time on Wednesdays. That's my for sure time. But whenever it's kind of like on TikTok, it's whenever I have availability, and depending on the group and stuff. But it's the same thing on, but it's on YouTube. And then with that one, it's usually geared towards either my classes, my books, or anything abacus. Um, Thank you so much. Thank you so much for liking the live. Thank you for the follow. But yeah, if it's on TikTok, it's kind of like whenever really. Yeah, cause 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 there's so many other people. Like there's some people in Finland and in Norway and in uh Norway. Like there's people over there, and then there's Ghana. Like Sir Patrick is in Ghana. Is your user profile your? Yes, it's in my bio. It's Miss Lynette is my YouTube. So Miss Lynette is my YouTube, and it is linked in my bio. Um, but yeah, I do realize that when I go on the different times, it just depends on where everybody else is in the world. I do know that a lot of the people are in America, but there are those few that are outside of the America. So, um, yeah. Thank you so much. No, thank you. I'll try to make it then. If you wanted like a specific schedule, I'm there for sure. But if it's like whenever I'm on TikTok, it's whenever I'm on TikTok. But yeah. But it'd be great. It'd be great to see you. It'd be great to have. If you have any questions about Abacus, my classes, or my books, I'm there. I'm there to answer any questions, because it's all just about making sure you understand. And I have a parent that actually comes in, and she has all these questions about my classes and about Abacus and stuff, and it's like, yeah, and I answer all of them, and then obviously there's the replay, so TikTok, there is a replay for TikTok, but it's going to be on YouTube, and I haven't done that yet. And it takes time because I have so many videos that I do. So, all right. So if there's no other questions, thank you so much. Thank you everybody for joining. Thank you everybody for commenting and asking questions. I do enjoy, making sure that we're all on the same page and we're okay. So if you have any questions, let me know. Again, if like for sure, Wednesdays at 9 a.m. Pacific Standard Time on YouTube. And this is my YouTube. But if anything, follow me with TikTok and you get notified. So I'm not sure when my next live will be. So okay. Thank you so much for the hearts. Thank you so much for the hearts. If there's no other questions, I will be signing off. Thank you again. Have a good night, everybody. Have a good morning. Have a good day. I'm not sure where everybody else is in the world. Thank you so much for liking my live. All right. Bye.